Hello everyone. On this video we will be looking at calculating the amount of change and average rate of change. Alright, so starting off, let's put out our XY axis. So you have your X and you have your Y. Okay, so let's say this is your value X and this is your value of X plus H. Okay, so that means, let's say if your f of x is here, that will make this your f of x, and this point here, your f of x plus h. I probably should have moved it over a little bit, but we'll make it work. Okay, so if we want to find the amount of change, we just have to find the distance between your f of x and f of x plus h. Plus h minus f of x. Okay, so what does this tell us? The amount of change of f of x can be found on the interval from x to x plus h, where the change in really your y equals f of x values. Gives us the amount of change is equal to f of x plus h minus f of x. Okay, now your average rate of change is just a little bit different. The average rate of change can be found using your slope of the secant line. Which is f of x plus h minus f of x all over x plus h minus x, or f of x plus h minus f of x all over h. Okay, so that's how you would find your average rate of change. All right. Now, what if we are given just, let's say, part of our average rate of change formula? Okay, we were given our f of x plus h, but not given our f of x, or not given our h, or not given any part of it. You can actually figure out the missing part. Okay, so I'm going to start that on a different line. So if you're still writing, feel free to press pause, but we're going to go ahead and finish that up on the next page. Okay, so to find those missing parts, we start with the fact that we know that f prime of a is equal to the limit as h approaches 0, f of a plus h minus f of a all over h. All we did was, instead of x, we used x for a specific value of a. So instead of f of x, f prime of x is f of x plus h minus f of x all over it. We just use a specific value for x. So that's why the a is in there now. Okay? Now, we know that if h gets really close to 0, it gives us our f prime of a. But instead of making a get infinitely close and closer, and it's just going to keep getting closer and closer and closer, what if we just pick one value of h that's really small, almost infinitely close to 0? Almost. We're just going to pick a really small value. Okay? So if we pick an almost, that's the key, infinitely small value, for h, then we can see there that our f prime of a is almost equal to f of a plus h minus f of a all over h. It's not exactly equal to, because it's still a little bit off. But if h is just really close to 0, then it's not that big of a change. Okay? So say we go ahead and multiply both sides by h. So h times f prime of a is equal to f of a plus h minus f of a. Okay, so if we add f of a to both sides, we see that f of a plus h, oh, that's my almost equal to, there we go, is almost equal to, let me clean that up some. F of a plus h times f prime of a. So we just added f of a to both sides. Well, I kind of switched that around a little bit. Okay, so really this can work for any of those, but this particular formula shows that we can approximate the value of f of a plus h if we know f of a, f prime of a, and h. And actually it could work for any of those values. You could just isolate them and then solve for that missing value, as long as you know the other three. Alright, so let's go ahead and put that into practice. Okay, so if you're still writing, feel free to press pause, but we're going to go ahead and move on to our first example. Okay, so what if we know that the population of a city is tripling every 5 years? Okay, so if the current population is 10,000, what will the population be 2 years from now? All right, so let's go ahead and start on this one. Okay, so what we'll do is we'll let P of t represent the population. In t number of years. Okay, and we'll have P of t is in thousands. So clean that up a little bit. All right, so the one thing we know is that the current population is 10,000. Okay, so our initial point of P of 0, we'll let that equal 10. Let me say that's 10,000. And we're just doing that because this way when we plug in everything, we don't have to, use all the thousands. We can just use 10 and we'll kind of know from there. Okay, so we know anytime we see a 10, it's 10,000. If we see 5, that's 5,000. So we can kind of go from there. It just makes the smaller numbers easier to work with. Okay, so what do we know? We know that the population triples after 5 years. Okay, so if we know the population triples after 5 years, we know that the population after 5 years is equal to 30,000. Remember, that's just here. And if you want to write 10,000 here and 30,000 there, just to, if it's confusing you to have 10 and 30, definitely feel free. You can do it that way. I'm just personally writing 10 and 30, so you're not pumping in all those zeros. Okay, so, of course, remembering that if we remember that f prime of a is approximately equal to f of a plus h minus f of a all over h, we can use that formula right here. So we know, well, instead of f prime of a, we're using the population. So that's p prime of 0 is approximately equal to the population after 5 years minus the initial population all over 5 minus 0. Okay, so what does that give us? P prime of 0, what I keep putting the equal when it's the approximately equal to a population after 5 years, which is 30,000, minus our initial population, which is 10, all over 5 minus 0. Which gives us 20 over 5, so that means that our P prime of 0 is equal to 4. Or it would be 4,000 if you were actually using that value. Okay, so that's our rate of change. Alright, so let me move that up a little bit. Now, if you remember, also, our f of a plus h is approximately equal to f of a plus f prime of a times h. Okay, so our population after 2 years is approximately equal to, because remember we're going from 0 to 5. We mean 0 to 2. Okay, so that's approximately equal to our starting piece of 0 plus p prime of 0 times our h, which is 2, because we moved 2 years. Okay, so just to kind of clear up where we got that from, we started at 0 and we're looking at 2 years. So this is our x, and this is our x plus h. That means your h is equal to 2. As you went from there to there, so your h is equal to 2. Okay, so in case you were wondering where these numbers came from. Alright. So that means a population after 2 years. Our initial population is A, well, 0. These are 0. We know that's equal to 10,000. So that's 10 plus our P prime of 0 is 4 times 2. So that means our population after 2 years is approximately equal to 18 or 18,000. Okay, so what this tells us is that population will be approximately 18,000 after 2 years. Alright. So if you are still writing, feel free to press pause. But we're going to go ahead and do one more example. Okay, so let's say if a population of a small town can be modeled by the function let's say P of t is equal to negative t to the third plus 5t plus 1200, where t is measured in years. Okay, so we want to use P prime of t to estimate the change in population between year 6 and 7. Okay, and we want to compare this to the actual population change. To the actual population change. Okay, so what we want to do is we want to estimate it and then plug in to find the actual change and then compare just how far the estimation was off. Okay, so let's say using P prime of t to estimate the change in population. Okay, so we know P of t is negative t to the third plus 5t plus 1200. So our P prime of t, our rate of change, is equal to negative 3t squared plus 5. Okay, so now what we're going to do is we're going to look at t equals 6. Okay, so at t equals 6, we know that P prime of t is equal to negative 3 times 6 squared plus 5, which equals negative 103 once you're done calculating all that. Okay, so what does this tell us? What this tells us is that, so at t equals 6 years, and I'll just kind of underline that, the estimated rate of change was negative 103 people. Okay, so what they're saying is at the 6-year mark, it's at a decline, it's decreasing. Okay, so they lost 103 people going between 6 and 7 years. Now the actual change in population is a little bit different. Okay, I'm going to go ahead and separate it. Actual change in population. That's the population at 7 years minus the population of 6 years. So the population at 7 years minus the population 6 years. Okay, so that gives us negative 7 to the third plus 5 times 7 plus 1200 minus negative 6 to the third plus 5 times 6 plus 1200. Right? So if we go ahead and just get rid of the parentheses by distributing, we see here, well, go ahead and just write it out. Negative 7 to the third plus 5 times 7 plus 1200 plus 6 to the third minus 30 minus 1200. So you can see those two cancel out. I didn't want to do it up there, but I'll go ahead and do it down here. Okay, so what does that give us? Negative 7 to the third is negative 343 plus 35 plus 216 minus 30, which is equal to negative 122. Okay, so here you have negative 103 that we estimated, but the actual rate of change is the negative 122. So it's the actual decrease between year 6 and 7. Okay, remember we used our population formula. Okay. Okay. So we know that if we estimated 103, but it was actually negative 103, and it was actually negative 122, then the estimate was off by 19 people. Okay, so in other words, we were close, but we were off when we used the estimate. But that's why they call it an estimate. It's never going to be exact. Okay, it's just a calculated guess. All right. So hopefully this video made sense, and I will see you on the next video.